Welcome back to 205A for single family services, and now we're going to look at how to choose the correct conduit size based on the wires that we've already calculated in part 2. So what kind of information do we need in order to determine this service conduit sizing? We need to know what our conductor gauge is, and we just discovered in part 2 that we're going to be using a 2-odd conductor. We need to know how many conductors we need to have inside our service. On a typical residential service, it is a single-phase service with dual voltage, 120 and 240 volts. What this tells us is that we will have 2 hot conductors, but in order to get that dual voltage, we need to have a neutral conductor as well. So on a typical residential service, we will have 3 conductors. Be aware that there can possibly be a 3-phase service inside a house in certain areas. Usually areas that used to be commercial and have become residential after the fact. In Medicine Hat specifically, there are areas within the Flats and Redcliffe that do match this description. So make sure you know what the service is before you start calculating this. For us, we only have 3 conductors. The next thing we need to know is what type of insulation do we have here? Different insulations have different thicknesses. Therefore, we have to accommodate that with our conduit selection. So make sure you know what type of insulation you have. We have an RW90 600 volt unjacketed insulation, and all that information is useful to us. Lastly, we need to know what type of raceway we're going to use. If we have an underground service, we are automatically going to use a PVC conduit, in which case that is what we've chosen for this particular house. If we have an overhead service, we could be using EMT or rigid or PVC depending on how that service is being built. Once we have all that information, then we have a few steps to follow in order to figure out what our service conduit size is going to be. Table 6 deals with the different types of insulations and gives us the actual cross-sectional physical dimension of our wire. So we need to know what the gauge of wire is, and we need to know what the insulation type is. Table 6 also automatically does a calculation for us when it comes to number of conductors as well. When we turn to Table 6A, this table is for RW90 600 volt unjacketed conductors. We're going to cross-reference the conductor size of the number of conductors. So we're going to take our 2-odd conductor, cross-reference it with 3 conductors, and as we find where those 2 intersect, we determine what the total area is for millimeters square. 3 2-odd conductors will occupy 425.61 millimeters square of space. So this is our first step. I want you to be aware that we can also use Table 10 in the exact same way. The only difference between Table 6 and Table 10 is with Table 10, you have to do that calculation yourself, whereas Table 6 will tell you the area of the number of conductors that you have. Table 8 will tell us how much maximum fill that we are allowed to have within a conduit. In order to make sure that our conductors don't overheat, we want to make sure that there's enough airspace in there for the conductors to cool off. We also have to make sure that we can safely pull in and pull out our conductors without damaging them. Table 8 gives us the value to make sure that we can meet these 2 conditions. In order to use Table 8, we need to find the number of conductors in the conduit, which is 3 conductors. Then we find this value within the table to identify the percentage. In our case, for 3 conductors, we can fill that conduit up to a maximum value of 40%. These 2 values that we have between Table 6 and Table 8 are going to be used in our Table 9 set. The Table 9 series is split up as far as what your percent fill in, as well as what kind of raceway type you're going to be using. So we have to look for the proper table that's going to deal with 40% fill, as well as the table that's going to include a rigid PVC conduit. In our case, this is going to be Table 9G. Within Table 9G, find the raceway column that states rigid PVC conduit, and then follow that value down until you exceed what we found from Table 6. When we go down the PVC conduit on Table 9G, we find the value that is exceeding 425.61 millimeters square from Table 6, and we've traced that across to find that we will need to have a trade size 41 conduit. Now we know how to find our total area that our conductors are going to be occupying using Table 6. We know how to find our maximum fill rate from table 8 at 40%, and then we know how to use those two pieces of information in the table 9 series in order to find out which conduit we are using. Make sure that you're going to the proper fill table and then use the proper conduit column in order to find your information. So there you have it. According to our house that we had, which is 130 meters square per floor of a 2-story house with a full basement, with all those specific loads that we talked about, we went through Rule 8110 to determine what our living area is. We used all the rules within 8200 to find out what our total wattage would be in order to find out our total calculated ampacity. We used our total ampacity in Table 2 to find our conductor size of a 2-odd conductor. Then we used tables 6, 8, and 9 in order to find out that we need to use a trade size 41 rigid PVC conduit in order to do this installation. We've now reached the end of 205A, so make sure you're going through the module information, go through the tests and all the other information I have for you on Blackboard, and if you have any questions whatsoever, reach out to me and I can help you out. When you guys are ready, move on to module 205B.